And let's start. So hello, everyone. My name is Mina Freeman. I'm the president of UBC Design League, and we're a new club in UBC. So thank you for joining our workshops. We're going to have workshops every Saturday. I know today's a Monday, but today's an exception. Normally, we'll have workshops every Saturday, alternating between engineering and architecture CAD topics. We also have design-a-thon competitions that are like hackathons, but more for CADing, and they're coming up next term. So if you want to just develop your skills and eventually end it with a big bang and join these competitions, I would highly recommend that. You can check all of our links through Linktree. I will send this again in chat, and feel free to join our Discord community to be notified of future events. So Colin, you can take it over.
All right. First of all, I'm gonna do a really shameless plug. My name is Colin. Currently I'm a second year for mechanical engineering at Ontario Tech University. Obviously, it's in Ontario. I come from a group called Redline. Basically, what we strive to achieve is that currently we're a student-led project team, and what we try to do is conduct cross-university projects. So if you're similar to what design leagues are, they're normally localized to just students in that same university, but what we're trying to do is have a governing body that people from different universities, students from different universities can conduct projects with each other. So we just thought that sort of big, large-scale projects, small-scale projects can all be accomplished by people from different backgrounds, different places, different universities. That's what we're trying to do. We also conduct other stuff such as competitions and also networking events. So I'll tell you more about that during the end, but I'll just move on really quickly into what you all came for, so which is SolidWorks. I'm going to assume maybe not everyone, but most people have SolidWorks installed in your computer. Yes, no, in the chat. If you have SolidWorks installed. And also, well, I would say again, if you can run SolidWorks simultaneously with what I'm doing right now, that'd be cool, just so you can, just work with me. And if you're running into any problems, just like type in the chat or just unmute your mic, and I'll be sure to sort that out. Okay, so I'm gonna start with sharing my screen. Share screen 1. All right, this is let me start from the very beginning. This is how SolidWorks should appear to you guys. First of all, what we're gonna go over are these right here, this list I made. These are the basic skills for what you'd need for the CSWA exam. You need to know how to sketch entities of different shapes. You need to know how to use the smart dimension, offset and trim entities. You need to know your sketch relations. You need to know how to make an extruded boss or extruded cut features using Revolve, sweep, and loft features. You also need to know the conditions for these features. You need to learn how to use a rollback feature, convert entities, fillets and chamfers, materials, mass properties. And obviously, once you've made your individual parts, you need to know how to assemble them, making them into one singular assembly through certain mates and your components. All right. Most of that might have not made sense to you, but don't worry, this whole workshop, I'll make sure that everyone should have a solid understanding of how to model stuff, how to assemble stuff, and how to make good drawings. Okay, first things first, how do you actually open a file in order to start working on stuff? Simple, Control N. Once you Control N, it should say, do you want a part? Do you want to make a part? Do you want to make an assembly? Or do you want to make a drawing? We're going to start with a part, just plain and simple. So you can do that on your own computer if you are working simultaneously with me, that would be cool. And first, we're going to talk a bit about sketching. So the way I like to look about it, there's someone in the chat. The way I like to look at it is that CAD software normally deals with 2-dimensional and 3-dimensional planes. So basically the way you think about it is that sketching is making the 2-dimensional object, and extruding boss and base is making that 2-dimensional shape into 3 dimensions. So basically I'll explain what that means. So for example, if you go into your toolbar, there is this option called sketch. You click that, then you click this. This basically means that you want to start a sketch. Once you click that, you're presented with this. These are the different planes on which you can sketch a shape: the front plane, the top plane, the right plane. I'm going to do one on the top plane. So once you click the top plane, it's going to bring you to a normal angle towards the top plane. So you can see it, and you won't be sketching on an angle. So there are different shapes for you to sketch. You can use a line, you can use rectangles, you can use circles, you can use arcs, you can use everything. You can even use splines. I'm going to do something simple and just go with a rectangle. And even in that rectangle, you can choose different ways to sketch that rectangle. If you click this drop down right here, you would see if you want to sketch it from the corners, from the center, a 3-point corner rectangle, a 3-point center rectangle, or a parallelogram. I'm going to do the easiest one, just a corner rectangle. I'm going to click here, and you basically just click and drag, and there you have your a rectangle. So that is the 2D shape. And once you have that 2D shape, that's when you work with all the features in order to make that 2D shape into a 3D model. But before we do that, there are some things that I want to do first. I want to modify my rectangle to the right shape and everything. So first things first, if you look at the bottom right, you see your length, your units, the units you want to CAD in. It can be meters, centimeters, millimeters, pounds, or it can be a custom thing. I'm personally just going to go with millimeter gram seconds because that's mostly the same unit system that the CSWA will be using. So I just suggest you guys use it too. So MMGS is what you should be looking for in the bottom right dropdown. Once you have that, you right click on your sketch, then click edit sketch. This just makes you go back to the original rectangle that you just sketched, sketch one. And there's this awesome tool called Smart Dimension. It's in the sketch toolbar right here called Smart Dimension. This basically allows you to modify the lengths of all the lines that are encompassed in your rectangle. So once you click on that tool, then let's say I click here, then you see that, okay, this line is has the length of 176.25 millimeters. And if you want to change that, you can just click, and let's say I want to change it to 80 millimeters. So I just type 80, and there you go. It's changed to 80. And let's say I want to change this line to maybe 60. So I just click it again, 60, and there you go. I changed to 60. So this Smart Dimension is going to be your best friend when you're trying to model 2D shapes, because it can basically allow you to modify the length of really any line or any points you'd need. You can even use it to modify angles, but since it's a rectangle, obviously we don't need to modify angles just because every angle would be a 90-degree angle, and I don't want to change that. But there is a cool thing that SolidWorks has in combination with the Smart Dimension. It's called the power trim. So first of all, let me start by sketching a line somewhat in the middle of this rectangle, sort of like that. So I just sketched a line right there. And there's this neat tool called the power trim. So if you look at your sketch toolbar, there should be this option right here called trim entities. Someone open your mic, they have a question. Is there a question? Guess not. So there's this cool feature called trim entities, and it basically allows you to modify it even more. So if you want to trim one of your sketches, you click that. Then you want to click power trim, and you see how I put this line pretty much in the middle of my rectangle. So if you click power trim and just drag your cursor around your sketch, as you can see, it deletes the lines that it goes through, and it basically allows you to form that rectangle with that new line I created. So all those lines that I just went through are being deleted. So it's just a neat tool you can have if you want to further sort of customize your rectangle towards the desired shape or not. And then to make sure that what I did was actually true, if you actually take the Smart Dimension of the new line right now, you can see it's pretty much exactly around half of the length that it was originally there. So now you know that I did cut it in half, which is what I wanted to do. Now, one thing that I don't like is that, as you can see, this right here is the origin. This is the origin of all sketches, and my rectangle isn't really at the center. So I do want to change that. And how you can do that is with this thing called sketch relations. So basically, first you unclick your smart dimensions just to let SolidWorks know that you're not dealing with that anymore. Then you really just hover over this line. Then you want to actually, you have to exit your sketch too. Then you first start by hovering over this line because you really want to get this right here. There's this dot right here, and you want to click that. Click the wrong thing. It is really tricky. That's why I advise you using a cursor anytime you're CADing rather than like a trackpad. It would just be easier for you. So once you click that midpoint, you can also click the origin itself. So now I have these 2 points selected, and if I want them to basically be vertical with each other, you just add the relations vertical. Any questions so far on what I just did? I basically wanted to center my rectangle on my screen and then that whole top plane. Any questions? No?
Yeah, I have a question.
Yeah.
Did you have to deselect your sketch to get that little dot? Because I'm not able to like find it.
To get the
were you
dot?
still, yeah, to get the little dot. Did you have your sketch open or was it closed?
Oh, so my sketch is currently selected, as you can see here, but
Okay.
when you're trying to make, so I can do it again. And if you still have problems, just let me know. So basically I discard changes to my sketch. You first, right click sketch one, edit sketch. That's what you want to do. So this top line right here, just hover over it and you would eventually come across the dot right here. Select that. You deselect the wrong results because I accidentally selected that. But yeah, it's the midpoint that I wanted to select, and you can see it selected. Then you hold Control to select two things at the same time, then select the origin right here. If I can do that. So now I have both the midpoint of this line and the origin. And because I want to shift this rectangle to the right to make sure that they're both on the same vertical line, in this tab right here that says add relations, I just click vertical. So now I made them vertical to each other. So yes, you do have to select the actual entity that you want to add that relation towards, if that answers your question. If it doesn't, just let me know, then I can explain a bit more.
No, that's good. Thank you.
All right. So once you've made that, I basically managed to center my rectangle on what I wanted, which was, yeah, I just want to center it on my screen, center around the plane, just makes things easier. Now, after that, so far we've discussed how to make shapes, how to use a smart dimension, and how to trim entities, and how to add sketch relations. By the way, because this workshop is 2 hours, I do suggest that you play with it on your own time, because I'm really just giving you a really good framework as to where to start your learning, but don't assume that obviously that when you're done with this workshop, you can get 100%. Really, a lot of SolidWorks skills come from actual experience rather than lecture. So I'm really just providing you with the basic details as to what you should actually seek to learn. So obviously, because there are other shapes that you can sketch with, I'm just using a rectangle because it's pretty basic and it would give you a good idea of what you should expect from SolidWorks. So after we've done that, now we have our 2D shape. Now we want to make it into a 3D model. So once you have your 2D shape, you go towards the features toolbar, and that's where you see all the 3D edits that you can make. 3D boss, extruded boss, would basically stretch your 2D shape onto a 3D plane. So it makes it from, like X, Y, it adds that Z factor to it, as you can see in that animation. Revolved boss basically rotates your 2D shape on an axis to make it 3D. I'm not sure if everyone is familiar with, obviously, I'm not sure if everyone has done calculus, but basically once you have a line on a 2D plane, you can basically rotate it around the x-axis or the y-axis, and in that case, you'll be getting the volume. So this is sort of the same vibe with it. A strut bosser base is basically making your 2D shape travel alongside a spline. Don't worry about, if you still don't understand it, I am going to go through each of these features just so it can resonate with you more. but we're going to start with the extruded washer base. So I'm going to stretch my 2D shape on a 3D plane, as you can see here. And SolidWorks has really good UI, so you can either use the arrow to drag it up and down to see how high you want your 2D object to be, or you can be a bit specific by just manually inputting the dimension over here. So let's say I want it to be 30 millimeters high. There you go. Then you click OK. And there we have it. Now we have a 3D object. Any questions so far on what I just did? I'm just going to be continually asking this just in case for those who are sort of modeling alongside me, just to make sure we're all on the same page. If not, then I'm going to continue. So one thing that is really good about SolidWorks is that they allow you to backtrack a lot. So even if you're done with this and you realize, oh, I need to change something. I need to change something that I did before. If you see this blue line on the side tab, this is basically your rollback feature. So think of this whole thing as a timeline. And this blue line is where you're at right now. So if you want to sort of go back in time and change a small feature that you did, just so you can make things more suited towards your needs and go back in time towards your current timeline, you can do that in SolidWorks. So you basically drag this line up, and as you can see, we're back to the time where I didn't create that 2D shape. And now, like if you've made your edits and everything, you can drag the line again, and now we're back to the future, if that makes sense. So this rollback feature is definitely going to be your best friend, because as you're CADing, you get tired, you might miss a few details. So this is more advanced than a basic undo button, because it really makes you be specific as to which point in time you want to go back towards. And once you go back towards that time, you can edit your features, edit your sketches, and go back to the future on your current timeline, just so nothing would be misplaced and everything, all the features will be towards your needs. But now we've made our extruded boss. Now we've stretched our 2D shape onto a 3D plane. But what if we want to make a cut in this? So first thing we do, we find the face that we want to make the cut on. So I'm going to say I want to make my cut on this face right here. So what I do is that I right click this, and all these icons here, you look for the one called normal to, that basically puts the camera, us, at an angle normal to the shape, just so we wouldn't be sketching at an angle. You never want to sketch at an angle because it's really in a perspective view, and you want it to be normal to that view. So you click normal to, and now we're normal towards that shape. And let's say I want to make a circular shape on this surface, then cut basically a circular hole through this block. And I can do that. So what I do is I select this face, then I sketch on this face. And what I do is that I start my circle. Again, there are different ways to create a circle. You can start with the middle, or you can build a perimeter around a point that you want the circle to be on. But I'm just going to be simple and start with the middle of the circle. So I just click anywhere in the rectangle, then I just drag my circle here. And let's say I want my circle to be this big. But if you don't want it to be that big, again, the smart dimension is your friend. You can tailor it towards your need. If you don't want to be 29, it can be, let's say, 25. And that's fine too. All right, so now that you have the circle, now you have the size of what your hole wants to be. Now you have that 2D shape. You want to make that 3D hole on your 3D model. All right. And again, anytime you're doing anything 3D, once you're going from sketch, you go to features. So now we've dealt with extruded washer base. Now we're going to deal with extruded cut. Extruded cut doesn't make the circle, doesn't stretch the circle on a 2D plane. Rather, it makes that circle into a hole that can be cutting through your models. So extruded cut is what you're looking for. And if you're working on a cursor, you can basically click your cursor wheel and basically move it to basically just see how your hole is going to be on your model. So let's say, yes, I want my hole to go through the entire thing. Or if you don't want it to go through the entire thing, you can again just drag this arrow right here. And if you want the hole to stop at the middle, that's fine. If you want it to go all the way through, that's fine. But I want mine to go. And we do this on a trackpad. I'll be honest with you, CADing is pretty hard on a trackpad. It's definitely different movements. It is possible, probably, because I'm pretty sure SolidWorks accounted for that, but it wouldn't be as precise as a cursor. I'll show you that later on how to do it on a trackpad though. But once you make
Colin?
this, yes.
Sorry, your microphone's kind of like making a strange sound at some points. Would you be able to just disconnect and connect it again? Maybe that'll fix it.
Yes, no problem. I'll be back in a jiffy. Then give me a sec.
Yeah, the workshop
All right.
will be posted on YouTube.
All right, how's that?
Yeah, this is
Good?
better.
All right. Honestly, the reason why is because I probably do a bit of my Mac, so the audio drivers are messing up. But don't worry. Tell me if my voice gets weird again.
Yeah,
Then
no
I'll do the same thing. Okay, so back to SolidWorks. Full screen, share screen. Can you make me close, please?
Yep.
Are there any questions on what I did so far? I feel like I went through a lot and not enough people have questions. I know I would definitely have questions, but if no one has, then you're just a bunch of really smart people. Okay. Back to what we were doing. Okay, so now we made the hole. Now we determined how big we want it to be. So I click the check mark, and there's our hole. Now we just to reiterate what we did, we clicked the surface, we sketched on the surface, we used the extrude cut feature to determine how deep we want our hole to be, and we made the hole. We clicked the check mark, and now we've made that hole. And again, like just to show you how efficient this rollback feature is, you can literally roll back to the point in time where you just finished your extrude, but you haven't started your cut. So if you do that, now we're back to the point where we didn't even start doing the cut. But if you want to roll back to go back to the future, now we have sort of rollback is your friend, smart dimension is your friend. It really helps. I'm telling you that right now. Okay, now you've learned how to create 3D models. Now you've learned how to cut on those 3D models, but we're going to do a bit more advanced stuff. First thing you want to do is, a lot of the times when you're just engineering in general, people don't really like to have sharp edges. So there's this feature called fillets and chamfers. It's on your feature toolbar, and it looks like this. This is what you should be looking for. Fillets and chamfers basically instead of sharp edges, they offer a curve, which might be for aesthetics, might be for safety reasons, whatever you want. They're there for you. You can click the drop down if you want to have a chamfer instead of the fillets, but I'm just going to make a fillet. So how you use these features is that you click the edges that you want to make them on. So if I want to make it on this edge right here, if I can click it, this edge right here, and I want to make it on this edge too. Yep, that's good enough for me. And again, you can alter the radius of the fillet because it's a circular shape. They don't really use length to measure how big you want it to be. They use radius because it's that circular path. I'm going to make it, let's say 8 millimeters. That's good enough. Once you're done with that, you just click the check mark, and there you go. Now you have the fillets. You don't have those sharp edges anymore. You might even do it not for safety, but really just to make it more aesthetically pleasing, which is fine too. But that's how you do that. If you want to add a chamfer, it's really just the same procedure again. So you click this icon right here, but this time you click the drop down and you select chamfer. Then you click these edges right here, whichever edges you want to add the chamfers on. I'm just going to click these edges right here. this is where the cursor really comes into play, because I'm not sure how accurate you can be on the trackpad, but again, you can alter the length and the angle of your chamfers. I'm just going to make it into 5 and 45 degrees, which is fine with me. Okay. And now to answer that person's questions about how you rotate your model with a trackpad, if you don't have a cursor wheel, what you can do is that you can go to this toolbar right here, and there's this thing called view orientation. If you click that, you can basically see, okay, I want to go to the top, I want to go to the side, I want to go to the bottom. And yes, that's how you can view the different parts of your model while not having that cursor wheel. So, oh, remember to save your document, guys. That's one thing. I'm not going to save this because I already have a document ready for you, but remember to save every now and then, because, you know, CAD in general, it's really frustrating when you crash. So save consistently, rule of thumb. Yes, you can press space too. Either that, or you can right click and this wheel comes up. It's just different shortcuts, but whatever suits your needs, you can do that. I just personally like using the cursor wheel because I just feel it's faster and it allows me to view it at my own custom angles. All right, next, we figured out how to make 2D shapes. We figured out how to use the smart dimension. We figured out how to use the trim entities, sketch relations. We figured out how to do an extruded boss, how to cut holes. We figured out the rollback feature. We figured out fills and chamfers. But now let's get into the more advanced ways of making 3D models. So if you want, you can save this, but I'm going to make a whole nother model right here. So don't save for me. And I'm going to make another part just to show you some of the new things that SolidWorks installed. Okay, so back to square one. Let's say I want to make a sketch on our front plane, do the same thing, sketch, and let's say the front plane. Now what you can do is that you can start with, I'm going to start with a circle. Simple, easy enough. I start with a circle, basically that size. And before I do my measurements, just remember to change your units. It can be any unit you want, but I'm just going to go with MMGS. Right click your sketch, edit sketch. And one thing I like is that you can, it doesn't always have to be a sort of a linear extrusion. You can extrude to make 3D models at different angles. You can even do revolve or sweeps. So that's what I'm going to go over right now. So in order to do, let's say we're aiming to do a revolve, which basically rotates your 2D shape along an axis to make a 3D model. So what we do for that is that we first make some construction lines just so they know which direction we want to revolve around. So you go to sketch, and let's say we want to make our axis. So we want to make a line, but not just any regular line. You have to click the drop down and click center line, because that's going to be the center of our revolution. So you just have to make it vertically, and you know it's vertical because of that yellow icon. And now we've made the axis for this circle to rotate on. And now we have that. We go to features, we go to revolve, deselect the line. Actually, no, you do select line because it's our axis of revolution, but you also make sure that the circle is what SolidWorks is referencing. So as you can see here, they basically took the circle and revolved it around the axis, and that's what we wanted. So basically they took this 2D object, revolved around the axis in order to make this 3D donut. So just so you know, there are more than one way to make that 3D object. It doesn't always have to be that linear extrusion. It can be in different ways. And this is an example of the revolve feature. There are other ways too, like you can make a swept boss or base, whatever suits your needs. Actually, yes, I did promise you guys I was going to show you the swept boss or base. So let's do that right now. So we're going to delete this feature, delete everything, but not if. By the way, do you guys have any questions about the revolved boss or base? Because I'm going to move on to the swept boss or base right now. If you have no questions, then I'll carry on. Or if you don't even know like what to ask me, just say that too, because then I'll know like if I need to reiterate myself somewhere, because I definitely have been in situations where I'm confused, but I just don't know what I'm confused about. So just make sure to say that too. Then I'll make sure to reiterate my last couple points. So now we're going to aim for the swept washer base, which is another way of creating 3D models out of 2D shapes. So I'm going to start with making a sketch. You always start with making a sketch. And I'm going to make it on our different planes. I'm going to make it on our top plane. Yes, I'm going to make it on our top plane. And I'm going to sketch a circle again. Circles are nice. I'm going to sketch a circle. Then I'm going to exit the circle. This is where the more advanced sort of techniques come in. Then I'm going to sketch again, but this time I'm going to sketch on a different plane. So basically what I just did is that this icon is always here. This is basically your design tree. And in the case that you're currently working with a feature, you can basically click this to view all the planes again. When you're dealing with swept washer bases, you want to make sure your second sketch is at a plane that is perpendicular to your first sketch. So since I sketched on the top plane, my next one should be on the front plane, if I can get it right. All right. That should be good. Yes. So we just right click the front plane so I can go normal to it right there. Now now that we have our shape, then we need the actual guiding line that is going to be swept around. So this is where all your splines or everything can come in. I'm just going to use a spline. It's easy enough. A spline is really just like a freehand form of sketching to make curves like that. You can just click the different points, and SolidWorks will automatically make those curves for you. That's good enough for me. Okay, so, oh, wait, it deregistered. Hold on. That's good. So once you're done, you just click the spline option. So now, as you see, you have two sketches on two different planes, and they have to be, like, absolutely have to be perpendicular to each other, or it's I'm like breaking up right now. The swept washer base feature is not going to work. Okay, so now we're going to start with the swept washer base feature. See, as you can see here, I basically replicated these two icons right now. First, you need your profile, then you need your guide path. So our profile, in this case, is going to be our circle right here. And our guide path is going to be that spline we created that's perpendicular towards the circle. And as you can see, SolidWorks took that circle and guided it around our path to make that 3D object. So this is basically what the swept path does. Once you have that 2D shape, it stretches it along that path in order to make that 3D object. This is particularly useful when you're dealing with tubing. So to make tubes, and you want to have custom sort of shapes for it rather than just like linear extrusion. You can make your own path and basically make the diameter of the tube and use this swept washer base feature to make that tubing according to the path you wanted. So I clicked my sketch, I clicked the path of my sketch, and SolidWorks did all that for me. And that's the finished product. Sort of like a tube. Next, if we are in the process of making a pipe, obviously this isn't really a pipe yet because nothing can run through it. So I want to introduce you to one feature that's called the shell feature. This basically creates an offset of your 2D shape and hollows it out. It basically hollows out your models. So what you want to do is go to the shell right here. And you click the 2D, you click the 2D surface that you want to make that start that shell from.
Sorry, I think Marco has a question. He just raised his hand up on Zoom. Do you have a question, Marco?
You have a question about this guiding tool. What
Yeah.
technique would you have if the guiding path and the profile aren't perpendicular together? So you want something maybe that's not this flat tube.
Yeah, so the reason why normally people try and do it perpendicular is because that's like a sure way to make sure that the sketches are connecting to each other. Because if they're not connected to each other, SolidWorks wouldn't be able to verify like which is the sketch and which is the guiding path. But in the case that you don't want it to be perpendicular and you want it to sort of be swept at an angle, okay, I'll just stop this. And in case that you want it to be swept at an angle, in that case, you wouldn't be using regular sketches. You'd be using this feature called 3D sketching right here, but that's sort of outside the scope of the CSWA, which is why I didn't go over it. If you want to learn about it, that's you can do that. But 3D sketching is basically instead of sketching on normal planes like front, top, and side, like left or right, you can sketch at any sort of angle at all. So you can sketch at multiple angles at once rather than like singular planes, which is really beneficial, but it's outside the scope of the CSWA. So I wasn't really planning on going on with that. But to answer your question, you would use 3D sketches to make that possible. But just for the CSWA, you would have to make sure that both the sketch and the path are perpendicular to each other and contacting each other, just so SolidWorks finds it easier to make that feature possible. Did I answer your question, Marco?
Yeah, answers. Thank you.
All right. So back to what we were talking about. We're trying to make a tube, but first we made the sketch, 2D sketch of the circle. Next, we made the path, the circular path that it would go through. And now we want to hollow it out. So if this tube like runs water through it, we want to make that hole that water can run through. So here comes the feature, the shell feature. It looks like this shell. And obviously you first select the face that you want to make the shell on. You edit your thickness. Let's say I want mine to be, say 0.5, maybe. I'm not sure if that might be too small or not. Let's check. Yeah, that looks too small. It did it, but it's too small, so it looks a bit awkward. I'll make that just a bit bigger. Let's make that 2. And there you go. That's your tube. As you can see, it basically made it hollow out the inside of your pipe. So now water can flow through it. Any questions so far on the feature I just did? We just went over how to create sketches on different planes. We just went over how to use the swept boss feature. And now I just taught you how to use the shell feature, which basically hollows out your models. For just to reiterate, for the shell feature, you really just select the surface that you want to shell out and select your thickness, basically the thickness of the shell. And yeah, you just click OK for the most part. And now we've created that hollow tubing that we wanted. Now, if there are no questions about all the modeling I've done so far, this is where we get into your answers for the CSWA. So basically how the CSWA is constructed is that they ask you to model an object, and you don't really submit CAD models, rather you submit the masses of those CAD files. So the masses in like kilograms or grams, and that's what you input into the system, and that's how they judge instantly whether you're correct or not. Which makes sense, because if you get a dimension off, it wouldn't be the right mass, right? So that's how they sort of evaluate their answers. So in order to get this, for example, assuming this was a question for the CSWA, and they wouldn't ask us to submit this CAD file, they would ask us, okay, so now that you've made this object that we told you to make, what's the mass of it? Because that's what they want. So what you would do is that you would get into the command prompt, top right corner, and you would search mass properties right here. And once you get this mass properties, you can click it and it will basically show you the mass. So my mass is 72 grams, 72.3 grams. And that would be my answer for this CSWA question. The CSWA question was to create a sketch on 2 different planes and make a tube out of it according to the dimensions I just used. And they wouldn't ask you for the CAD, they would ask you for the mass of it, just so they know you got it exactly right. I'm pretty sure they allow really only a 1% error. So like, you know, it can only be 1% higher, 1% lower. So they're pretty strict on your mass value. That's why you can't really just guesstimate it. You actually have to use the match properties feature to make sure you get it right. So in this case, my answer would be 72.30 grams for the mass of my pipe. But one thing they can do is that they can ask you to actually specify the material of your pipe. Okay, so right now, SolidWorks default setting is to make all your models steel, but you can actually change that. To the sidebar, you can basically click this, and it would take you, if you right click it and click edit material, you'd be able to basically show which material you want your model to be. And it has a plethora of materials. It has different kinds of steel, reinforced steel, hardened steel, wrought stainless steel. Let's say I want mine to be copper. And let's say I want mine to be a copper alloy, let's say aluminum bronze. So I click apply and I cancel this. And yes, the color change just shows that the material has changed. So it's sort of like the same value as copper. And once we click this match properties again, so go to command prompt, click mass, then you just type in match properties and it will show up match properties. Like that. And as you can see, my mass has changed. And this makes sense, right? Because I just changed the material that the pipe is made off of. So once you change the material while maintaining the same volume, due to the density and other properties, it's going to get either heavier or lighter. So because I made mine from steel into a copper alloy, an aluminum copper alloy, the mass went up to 535.05 grams. And that would be my answer for this question. So the basic formatting of this CSWA questions is that basically what they do is that they give you technical drawings of models. They ask you to model them, and they, in terms of your answer, they really just say, okay, so now that you've modeled this, what is your mass value? Because that's how we know that you modeled everything in accordance to how they wanted. So now that we've done the basic modeling of parts, although there is quite a bit left to cover, but I just want to really give you the basic SolidWorks UI and how to convert that 2D shape into that 3D model. Now that we've done that, now we can start venturing into the world of patterns. So patterns are a really fun technique. It's really meant for you just to help with workflow. In case that you have a model that has multiple features of the same thing inside. Let's say if you don't just want one of these tubes, you want 100 of these tubes, you wouldn't want to CAD 100 pipes individually, right? So patterns can really help with you just, you know, it makes a pattern, whether it's a circular pattern or a linear pattern, it basically helps with that workflow. So I'm not going to save this. I'm going to create another file. You can save yours if you want for future reference. But I'm going to create another file, create another parts. Like so. And we're going to start with a brand new sketch. All right, so sketch, and let's say I want to sketch for my front plate. All right, first thing you do is that you should always do this before you even start sketching. MMGS, just make sure to specify your sketch units. So I want to sketch my front plate. So let's say I want to make, okay, we've done a rectangle, we've done a circle. Let's say I want to make a slot. Different ways to make a slot: straight slot, center point, straight slot. I'm just going to be easy and say straight slot. So you have different ways of you making the slot, but you just click 2 different points and then you modify the radius and such of how big you want your slot to be. You click,
Colin?
and there's your slot. Yes.
Sorry, unfortunately, your microphone's making
My mic?
Yes.
Oh no.
Maybe if you just unplug your microphone and then re-plug it back in, would that help?
Maybe. I think the thing with the audio drivers is that it's embedded in the computer itself. Stop sharing for a bit.
Now it seems to be okay, actually.
Is that okay?
Yeah.
All right. I just switched my mic to an external mic.
Okay.
All right. Screen share. Okay. We just made the slot and now we want to, or yeah, I was going to show you about patterns. Okay. So now that we've made the slot, one thing you want, oh wait, I did not mean to do that. So let me just remake the slot once again. This. Okay. Next, now we want to make a pattern of this slot. So in the case that we don't want to sort of make the slot over and over, we can make a pattern of it instead. And how you do that is that you would go to Sketch and, oh wait, this is in the way. You go to Patterns. I'm going to move this. Okay. You can do patterns. There are different ways for you to make a patterns. You can mirror it on the plane, or you can make linear patterns. You can make, whoops, you can make circular patterns. I'm just going to make a linear pattern. So you click linear pattern. And if you want to make it on the x-axis, that's fine. If you want to make it on the y-axis, I'm going to leave it at x-axis. And you obviously have to click the sketch that you want to make the pattern on. Different settings. If you want to make multiple patterns, multiple entities, that's fine. If you want to adjust the spacing of these entities, you can. I'm just going to make two, just for simplicity's sake, and just make like that. That should be good for me. And as you can see, it basically made a duplicate on the x-axis of that sketch that I just made. Any questions so far? How late does this go? It goes till 9 p.m. PST. If you can confirm that. It goes to 9, but yeah, it goes to 9. But what I have planned is that from 8:30, that's when I really just work on a specific CSWA question. And I have 30 minutes attributed to that. So if you just want the basic ideas and basic framework of what to learn, 8:30 is when, what is CSWA? Okay, so I said CSWA is Certified SolidWorks Apprenticeship Program. Certified, it's basically an exam that you can take in order to get certified to show your SolidWorks skills. You don't need to pay for an actual online course for it. You really just pay for the exam itself. You go on the SolidWorks website, and yeah, I think again it costs like $99 or around there. If they change it, you pay for the exam and you can get certified to put on your resume for SolidWorks skills and all that. So yeah, it's really just an exam that shows your skills in SolidWorks. So now we've made the sketches, and one thing we can do is, so yeah, we can play with it. We can now that we made sketches, just to show how useful this pattern is. Now you can see that they're linked. So anything I do to this, it goes to that because they're part of the same pattern. So if I extrude this one, both of them extrude and all sorts of stuff. Sort of like this. And I think it's really useful, really helpful, because it really just eliminates, again, it really just eliminates that whole hard work that would be attributed as to making two different sketches and extruding them individually. So it really just links them and patterns it, which is pretty cool. Now, one cool thing I find about 3D modeling is that you can really choose to amend your models at any point in time. I taught you two different ways. Number one, you can use the Smart Dimension tool to edit your sketches, and you can also use the rollback features to really go back in a point in time to edit your features. But what if I wanted to change the height of my boss extrude right here? What if I want to change that? So let's say I want to make it a bit higher. So what I can do is that I can right click boss extrude, then now click edit feature. And as you can see here, like I go back to the original tab for boss extrude. So now let's say instead of 70, I want to make it 60 instead. So now I made it 60 and everything's good. So now they're both 60. So really, it just allows you to sort of edit those boss extrude features and be really malleable in your design rather than just having strict values that you can't Control Z for. So now we've gone over linear patterns and we went over how to edit your already made extrude. So what I can also do is show you how to convert entities. So converting entities really just applies or projects 2D sketches on 3D surfaces. So if you click here and it's a sketch feature, I believe, then what's it right here? Oh, it's the wrong one. Oops. Sketch. It's called offset entities. You click sketch and you click offset right here. As you can see right here, it basically took the sketch that made the surface, that slot, and you can offset it by any amount. If you wanted to basically have a distance of 10, you can. If you want to make it bigger, you obviously can't. But let's say I want to make it 10. Or actually, yeah, I'm going to make it 10. That's a good amount. And I click OK. It basically offsets the sketch that made the surface by a thickness of 10. And I can even go further and extrude this 2D sketch by a certain height. And if I do that, that's possible, as you can see here. The reason why this specific offset entity wasn't replicated on other members of its pattern is because I clicked this, like this surface specifically. If I can roll back my feature, I clicked this surface specifically, hence why it wasn't duplicated on its other. But if you want to duplicate them both, you just like hold control and click that. But I just wanted specifically on this surface, hence why I just clicked that, just so it wouldn't be replicated on its other brothers and sisters. But again, any questions so far on how to offset your entities or sketching in general? Because as of this point, we're pretty much good in terms of CSWA sketching. So if you have any questions about sketching, now's the time.
Yeah, I have a question about the sketching. Does this offsetting and resizing of the sketch work with more complex drawings?
It pretty much works with any shape. Well, I've never really run into a position where the offset entity wouldn't work. The only situation that I guess you can find an error in is if you put too much thickness on your sketch. For example, if you do the offset entities on the surface and you put a thickness of 1,000 times the length of the original sketch, then that might generate an error. But I don't think you'd ever run into that occasion ever. Or what situation did you have in mind specifically?
Like when you offset and then you resized it to be 10 millimeters bigger. If you were doing that with a drawing where it's a bunch of splines,
right,
and then you try to resize that, would the curve still look like that complex drawing? Yeah.
So as long as, okay, I get what you mean. Since it's like an irregular shape, it might have trouble sort of making that offset. But as long as your offsetted sketch doesn't intersect with the sketch itself, it should be fine. So Actually, let me see if I let me see if I can generate an error. That's even possible. Yeah, I'll use this one. I click here. Then let's say I want to do an offset. Right? Yeah, okay. Edit sketch. If I want to do an offset of yes, yeah, a quantity chosen too large. So again, like if you put a large enough value that the sketch intersects with itself, that's when it would be able to generate an error. So let's say I put, or even something too small, honestly. So let's say like -1, like that wouldn't, well, actually it would start actually going in on itself. If that's what you want to make it show, that's fine. But if you put -1, as you can see, it's not possible. Like it's just straight up not registering, because that's not possible to have like a -1 distance. But in the case that, like Marcos, to answer your question, in the case that you are using splines, it still should be good as long as like that eventual offsetted sketch doesn't intersect with itself, because that would really be an impossible equation for SolidWorks to solve. So it's really just being smart with your offset entities and making sure that sketch doesn't intersect with itself, like the lines don't intersect. But if all those conditions are met, I wouldn't see why an error would be generated. Does that answer your question?
Yeah, thanks.
Alrighty. Okay, so we've dealt with offsetting entities from surfaces and extruding that. Any other questions for sketches in general before I move on to assemblies? Because that's what I have next on my list. After assemblies, then we deal with like inserting components, mates. Then after that, we deal with drawings. And after that, I just walk you through some CSW, just one CSWA question. That's what we have left for the workshop. So if you have no other questions on sketching, I'm going to go ahead and work on assembly. Okay, I assume there are none. So don't save for me. If you want to save it for yourself, that's totally fine. Control N, and let's say I want to make an assembly. So I do have some pre-made parts that I'm going to attempt to assemble. The reason why just for time's sake, I just pre-made the parts just to fit in the 2-hour slot. But what I'm going to do is that I'm going to make a key. I'm going to make a key with like the key chain and all that. Let me just get all my files. So when you want to get a file, when you click that Control and start an assembly, you click Browse just to go through your directory. I have my directory on my other screen, if that's why you're wondering. You're currently not seeing it, but right now I'm just picking out all my components to use. Click Open. And once you click Open, all your components would start appearing. So you just click, click, click. Okay, so these are all the components I made. None of these should prove too hard for you guys yourselves to actually CAD yourselves. As you can see, all I did here was create that circular path and used swept washer base to make this turbo. Then I used small sketches to make that extrude cuts. Same thing here. I used the Revolve feature on this specific slot to make that link. Here is a simple extrude cut and extrude extruded washer base. Same thing here. I made a circular sketch that I extruded it. Then here, same thing. It's just an extruded washer base, but then I actually used like individual lines to make this sort of like ridges right here for the key. It takes a bit of time, but I use no skill that wasn't previously mentioned in this workshop. So theoretically, with due time and due experience, you guys should be able to make this. Obviously, you wouldn't be able to make this right now because you just need more experience with that SolidWorks UI and just to like get everything I've just told you right now. So once you have more experience with the skills I've sort of laid out for you in that basic framework, this should be in your skill set to make something similar to this. But now for the actual assemblies of this, what I strive to do right now is just basically make a keychain that can be used. So first thing first, once you insert all your components, what you're going to do is that you would want to, there's this thing called mates. And yeah, as you can probably tell, they basically link your components together in order to form an actual assembly. So there are different types of mates. You basically have to click this right here, safety pin. You click it, and those are your mates. It's in your top toolbar. And you start by clicking all the entities that you want to make. So there are different types of mates. There's the coincident mate, parallel mates, perpendicular, tangent, concentric, lock. I'll basically give you a good framework as to what most of them do, the major ones do. So the first one I'm going to go over is the coincident lock. So basically what these do is that it links two surfaces to be on the same plane as each other. So for instance, there's no better way to teach it than to actually like do it. So if I click this surface of the rod and I click this surface right here, as you can see, I made them in the same plane as each other. So they would operate on the same plane, which is good. That's what I want. I click OK. And I deselect the mates. And as you can see right now, no matter how I move my rod, it's always going to be on the same plane as that object. So that's what the coincident mate does. But what I actually want, like in accordance with actually making it on the same plane, I actually want it to fit in this hole right here. So this is where the concentric lock comes into play. And how I do this is that what the concentric lock does is that it basically mates the two axes of each of the circular entities together. So they make sure that like the two circular entities are sort of parallel to each other. So if I click the round part of the rod and same of this part here, the circular entities, as you can see, they basically pair the axes together so that they would be perpendicular to each other. And that's what I want to. So as you can see right now, they are fully defined in the sense that they are on the same plane and the circles line up, which is what I want. So I'm going to do the same thing, but in this case, I'm going to do it for this part right here. So same thing, I'm going to first make the concentric mates. Oh, we have a question in the chat. Oh, no, that's me. Never mind. Yeah, so I'm going to mate the surface with this surface. And again, that would just make them be in the same plane with each other. Then I'm going to actually do the concentric mates. So the circular entity and this circular entity. Most of the time, SolidWorks already knows what you're doing, so it would like auto select the mate for you, which is fine. So that's what I did right now. And as you can see, it's fully defined, which is good. This is what I want. It's fully defined. And one thing about assemblies is that, as you can see, anytime I like sort of click and drag this, it moves around. But in the case that I don't want it to move around, what I can do is that I can just like right click one of these objects. And as you can see here, if you right click it, there's a thing called fix. And once you click that, it's basically fixed to the spot. So it wouldn't move around when you click and drag it. It just makes it easier for this organization, but this can't. This can still like rotate. The reason why this can rotate is because it's paired with the axis of this and it's concentric, but there's no actual mate that's restricting it rotating around the axis of the rod. So it can still rotate around, which is fine. It's fine if it does that. Okay, next thing on the list is that I want to actually pair this key into this rod right here. I want to put this key first this component already seems to be fixed. So again, you can right click. So instead of fix, if it's already fixed, you would see float. It's either fix or float. Float basically makes you allowed to move it. But if you right click again and click fix, you're not allowed to move right now. So I wanted to move. So I'm going to right click and click float. Now it can move. And now I want to basically pair this hole right here to be part of this rod right here. That's what I want to do. So what I do is that, as you can already guess, it's a concentric mate I'll be using. So I click mates. I click the circular entity right here. And I click the circular entity right here. And as you can see, now they're paired with each other. I click OK. And as you guessed, it's now where it's supposed to be. It's sort of in that same axis. As you can see, it sort of like goes through the objects, because right now the only mate that's constraining its movement is just that concentric mate. But later I will talk about a fairly bit of an advanced mate that basically limits the movement to just from here to here. It's called a distance mate. I'll talk about that later, but right now I'm just going over the basic mates. So another thing I want to do is that this is a turbo I made. It's really just for aesthetics, doesn't really add to the keychain itself. I just want to slap it on this surface. It's just a turbo. So what I can do is that first I want this surface to be attached to this surface right here. So if I want to do that, I basically make a coincident mate, right? Because I want this and this to be on the same plane. So if I select this and I select this, that basically helps with that. So now as you can see, they're on the same plane. Click OK, mate plus fix. Here's the thing about fix. Fix isn't really a mate. It's really just to make the components stop moving, just for your actual organization of the assembly. So it's really just it's a temporary thing. It's just a temporary thing just to make sure that your components stop moving. So I guess a better explanation would be, think of the fix as sort of duct tape, but think of the mate as Gorilla Glue. So really you're just, the fix feature is really just like duct tape your model towards your desk so that as you're working on it, it just doesn't move around. But the actual mates is Gorilla Glue, because you actually want those two components to be bonded together permanently. So that's what the mate does. Fix is really just to help your whole assembly sort of procedure go easier, just because nothing's moving. So just a temporary thing, but the mates is the actual Gorilla Glue, the actual permanent joints that you're going to make. Got it? No problem. Okay, so now you've made the mate, the coincident mate, but what you were probably thinking of when you said fix was this lock mate. And basically this lock would be fixed, but if it was permanent, if that makes sense. So basically it locks a component towards a specific position. So again, the difference between lock and fix is that fix is just a duct tape, is just for organizing your components, so you can make the assemblies easier, but the lock actually locks it to that position permanently. So in this case, since you're already on the same plane, all I really have to do is position the turbo to where I want it. Let's say I want it here, and I would select the lock mate, and I would click any part of the turbo in any part of the keychain and lock, and that's fine. And if I click OK, as you can see, the turbo now moves with the keychain because it's locked to that specific position. If it was fixed, it would just be a temporary addition. So if you save your assembly and go back to it again, it might not be fixed anymore, because it's just duct tape for you to help with organize stuff. But since I use lock, it's permanently locked towards that surface. So now it's permanently joined there. It's basically, if I was talking about this in the physical sense, it's really as if I just used Gorilla Glue to like glue it onto the surface. Okay, next is to put this ring on here, on this hole right here. That's the next thing to do. So yeah, again, it's really just making sure, first you actually have to like move it to make it close. If you don't sort of align it yourself, SolidWorks might bug out. So I suggest just putting it on the right angle, just so SolidWorks would be able to like more easily sort of get which specific type of mate you're gonna do. So I'm just moving it to make it around here. This is what I'm trying to do. If you want to even rotate your components, you can right click it, and there's this thing called move it triad. So you can move it left, right, up, center, but you can even rotate it on an axis like that. It's called move it triad. By the way, I'm pouring a lot of information to you guys, so don't worry, it's being recorded. So if you want to look back on it, you can. So you can look back on it and do a bit more studying on your own if you want to see, know exactly what I'm talking about. But now that I've made it into the position, I'd in turn again be using the lock mate because I just wanted to lock it permanently towards this position and not move it anywhere. So I click mates, I click lock, I click any surface of this, any surface of that, and I click OK. So as you can see now, it moves towards the surface. Oh yeah, so I also needed to lock it towards the surface too. That's actually good that I ended up doing that mistake. So I also need to lock it towards the surface too. So mate, lock the surface and the surface. Click OK. So now it's locked towards both, hopefully, yeah. Now it's locked towards both. And that's pretty much how a keychain should look like. This is sort of like a Dollarama keychain you would find with the turbo. Any questions so far about mates? Yes, Marco.
On the loop, is there a systematic way of mating it so that it doesn't clip to your flat pieces? Because I think you just moved it manually, but is there a way to have it avoid it clipping, I think?
Like clipping to your, sorry, what do you mean by like clipping to your flat pieces?
Like the circle piece, it's fully in the holes. There's no part of the, no part of that coil which is hitting any of the surface. Because if you look at it, it's clipping with that flat part.
Right. Oh, I get what you mean, like this part right here, right?
Yeah.
Right. Okay. You can try a concentric mate, but the reason why I was shying away from that is because there are two different circular objects. So SolidWorks will bug out in that sense because they wouldn't really know like which axis to choose from. So I guess on my part, it would really just be on sort of like manually positioning it more. The thing about the lock mate is it locks it in position. So it is a bit manual in the sense that you have to position it yourself, but you can play around with concentric mates, but I just feel that's all would bug out if you try that, just because there are two different circular entities in this component, so it would sort of not know which one to choose from for that specific mate. So yeah, a lot of my sort of rule of thumb with mating is just that if you can't find the right, if you keep on running into errors with mating and sort of like figuring out, oh, it's a concentric mate or it's a coincident mate, if you don't know which, or if you don't know which one to choose, but SolidWorks just keep bugging you out, I suggest just using a lock mate because it's really just a manual process and it just locks it into that specific position. So avoiding from clipping it, yeah, again, it's really just me. Yeah, I can just roll back this. Actually, honestly, I'll just delete this altogether or edit it. Again, edit it. Yeah, I'll just delete the last two mates that I did because they do sort of intersect with each other, which doesn't look good. I just move it a bit upwards to make it look a bit nicer. that sort of. If I do that, mates. Oh, wrong one. Block. There. That should be a bit. It doesn't click too much, but yeah. Any other questions about mating? After this, I'm going to go over appearances just so you know how to get these different colors. But so anything about mating specifically, though? Or if you need me just to reiterate what type of mate I did for what. Get a certain part of this. Oh, okay. Good thing I touched that. I forgot. I needed to show you how to do this distance mate. Okay. So as you can see, all I needed for this was the concentric mate. But I need this, realistically, you would want the key would only go from here to here. So basically you would offer a distance mate that would make sure that this surface doesn't go past a distance constraint. So what I would do is that I would first pull it to my starting position, which is going to be pretty much here, and click mate. Actually, I selected the wrong surface, so I'm going to deselect that. Delete. And let's say I want, it's going to be, I want it to be a distance constraint, but it's going to be an advanced mate, this type of constraint. So this is one of the advanced rates. So I want it to be between this surface and this surface. So as you can see, what basically this mate does is that it establishes a minimum and maximum distance from the two mates. So if I want my minimum to be 1, that's fine. And this is the minimum, as you can see by the icon. And the maximum, I would make it a bit bigger. Ooh, not that big. Let's say, does 9 sound? 9's good. Okay. So I want my biggest to be 9, and I want my smallest to be 1. And basically, it just shows that, okay, so max distance from these two surfaces should be 9, and the minimum distance should be 1. Actually, technically, it should be 0, because that means they will be touching each other. Okay, so there we go. Okay. And that should fix things. So as you can see, I can't go any way like too extreme. I can't go past these boundaries right here. So minimum distance means you're touching the max distance when it should theoretically be touching the other one. Technically, it would be more than 9, but to get that exact value, you sort of have like trial and error to see when it's touching it. So, any questions about the advanced mate, the distance mate? Always remember to like go over this video over and over just to make sure it like clicks with you. But that's basically a quick rundown of how the advanced mate goes for distances. Any questions on mates in general? Any questions on mates, sketches, or modeling in general before I go to appearances and drawings? Nope. Okay, cool. All right, so that's a keychain. That's how you make certain assemblies. And now I'm gonna work you through how I made these sort of like how I made this gold, how I made this copper, how I made all this. So SolidWorks does a good job with rendering. I personally use my rendering in Blender, but SolidWorks does have its own rendering software. So basically what you do is that if you can see this right tab right here, you click appearances, scenes, and decals. If you click that, then drag it out, because for some reason mine isn't. Okay. Click the drop down, and you can see it has a plethora of different appearances you can make your components to be. Let's say I want this to be some shiny metal. So I would click metal, and chrome is usually shiny. So I'm going to click that, and I want mine to be a shiny chromium plate. So I put that here, and they give you different options of if you just want the surface itself to be shiny, if you want the whole part to be shiny, and stuff like that. So I just want the pad itself will be shiny. So I'm gonna click that. It doesn't show right now because right now it's really just, it's not rendered. It's just still in the modeling part, but I will render it in the future just so you guys can see the finished copy. So I made that into chromium, a shiny metal. I'll click appearances again, and let's say I want this rod to be made of bronze. Yes, let's say a polished bronze, which should be good. And I click yes, I want the whole part to be bronze and not just the surface. And yeah, I already put the appearances for this. Okay, let's say I want this ring again to be a different color. Let's say gold. Let's say a shiny gold. And I want the entire part to be shiny gold. And there you go right here. And that should be all the materials for the keychain. And now, once you've done all your materials, now you can have some fun with rendering. Rendering is honestly, in my opinion, the more fun part of CAD because it just makes your design look much more sleek. So for rendering, what you do is that you have to have SolidWorks Photo View 360. And that's basically an additional feature of SolidWorks that would help you to render models in greater detail. I think if your SolidWorks comes with your student, if you download your SolidWorks from your student website from UBC, they normally do offer Photo View 360 with it. So you should have it on there. If you don't, I'll tell you how to add it right now. So what you do is that you go to File, Tools, scroll down, and you go to Add-ins. Then you click Photo View 360. These are all the features I personally have with SolidWorks, but for rendering, yeah, photorealistic rendering, you just check Photo View 360 if you do have it, like that. Then you click OK. So now you should see it in the panel here and here to render tools. So you click render tools if you want to, if you're ready for render. And this is sort of the angle I wanted as for rendering. I click first, I can preview it or I can do the final render. I'm probably just doing the final render straight away. But first I need to add a camera. Camera is just really a point of view for what you want the render to be as. And let's say I want the render to be like sort of like that. Okay. I'm just making this really quick because this isn't officially part of the CSWA, but I just feel like if you're CADing in the future, you definitely want to see your renders of your models just for fun. So once you click that, click final render, and the screen should pop up that would start rendering your image. Don't worry if you don't have the best graphics card or nothing, because SolidWorks, I'm pretty sure SolidWorks uses maybe a late gen EV engine for those who are familiar with EV. So you can use basic CPU to render it, not just like you don't need no RTX or nothing. And that's what you're doing for rendering. Once you're done rendering, you can save image, save it as keychain. Those are my other renders. Okay, so you can save it as keychain and you can exit that. I'll show you the finished product. That's the finished product. That would be how it looks like once all the lighting and all the appearances have been added. That should be what your keychain would look like if you did have the CAD model and you did apply the right appearances. But any questions on appearances? Or anything else I've done so far in this workshop? I'm down to go back with like stuff I did in the very beginning if need be. No questions? All right, what's next on the list? Now we can deal with, now it's really just drawings. Drawings is, just engineering drawings, how to make drawings on SolidWorks. So now you're done your modeling, now you're done your appearances, you've done all the rendering, but normally when people want your CAD files, they also want some engineering drawings with it, just in case they want to make it for themselves, which is totally fine. So, you know, in unison with your CAD model, you would also make some engineering drawings with, and basically what they do is that they add dimensions just so they know how big it is, all the angles, all the sizes, all of that. And you can make that, instead of doing that manually, you can make that automatically with SolidWorks. So what you can do is Control N. And this time, instead of an assembly, I want to make a drawing. Okay. And it will take you to this part right here. This is basically a blank sheet you would use for drawing. And you click browse and you basically choose the part or the assembly you want to make a finally. You basically choose the part or the assembly you want to make your dimensions for. I'm just going to pick something simple. So I'm just going to pick a circular rod I previously made. So you can make different views like that. If you want to add more views, you can okay. You go like that. And let's say you want the right view, the left view, the back view. This is basically a circular rod, so nothing too fancy. So you can click the right view if you want to have it here. You can even have an isometric view. Basically, you would have to go back to this icon, click rod, and you can have an isometric view right here. And yeah, that's basically how you make the visuals themselves for your drawing. If you don't want these lines, you just click this eye right here and it would remove it. This cross right here is really just a center line, just so they know like the diameter and all that stuff. We'll talk about it later. But now that we've actually established the visuals of the drawing, now you can actually deal with actually annotating the drawing to actually give dimensions. So what you do is that you go to annotation, then you go back to our old friend, the smart dimension. Once you get the smart dimension, you can click on any line, then it would show the length of it, and you can put that on your drawing like so. And you can click this too, and it will show, oh, it has a diameter of 0.21. For this rod specifically, that's pretty much all the dimensions you would need, just the diameter and the length. But yeah, engineering rule of thumb: don't put dimensions on your isometric drawing. Isometric drawing is really just to see the design as a whole. But so you should really only put on your orthographic drawings. For those who are not familiar with the terminologies I just used, orthographic drawings are drawings that are at normal to specific surfaces of the object. So this is normal to the front plane. This is normal to the right plane. But isometric is really just viewing the object as at an angle. I think what it has that I think, yeah, I did my first year in UBC. And I think what you guys learned was that isometric basically an angle that would have the object at a 30-degree angle from the normal line, like cut through the half of it. So it's basically just like a view of the object at an angle. But what you should really be putting your dimensions on are the orthographic, which is the normal. And yeah, you can fill in all these details if you want, but I'm not going to, just because it's not really required for CSWA, just dimensions are in inches, all that. I transferred, yes, I did. Transferred. I'm a trader. Sorry. UBC is fun though. Good times. Transferred right before it went to like, actually no, I was scheduled for I was in the year that unfortunately have to suffer online classes. Not fun, but it was cool. It was a good learning. You have lots of learning opportunities there. But yes, any questions on dimensions or drawings? Any questions on that? No one? No questions? You're all geniuses? Okay, that's fine. And here's some other stuff you can do if you want. It's not really part of CSWA, but I just thought, since everyone can catch up really fine, you can add center lines to your drawings. It basically shows you the center of, as it says, it's just the center of your parts. So if you click center line and just click this, it just provides a center line. All this is like heavily automated, so it's really easy just to make drawings of this quality. So this center line basically shows this is the center of your the rod. You can even click the isometric drawing and it'll show you that too. Really good stuff. It just allows people to know like it's a circular object and the center line is the axis that the circular object is on. There are other annotations you can use for your drawings, but I wouldn't delve too much in that just because it's not really required by CSWA to do that. But yeah, that's pretty much it for drawing. Any questions? Yeah, I guess again, it's any questions on it. Because next is really just me going through past, like showing you like examples of past CSWA question. And after that, that should be what I have for you guys for the workshop. The remaining is really just Q&A on anything else. So if there's nothing on drawing specifically or anything else I've done, yeah, next is really just don't save. I don't need this. You might, but okay, don't save. Okay, so next I can show you some past questions that CSWA. I'm not sure if everyone here is planning on taking it, because I get the gist that most people are really just trying to like learn SolidWorks, which is totally fine. But it'd be nice just to show you, like, if you were to take it, what are some questions that might pop up. You might not be able to do everything right now, just because obviously I just gave you a basic framework as to like what you need to learn and how to learn them. But it should at least make sense to some degree, hopefully. Okay, so here's a test PDF that you would use. The CSWA exam, by the way, is 8 hours long. Not 8 hours, holy, 3 hours, 3 hours. Don't freak out. 3 hours long. It's 3 hours long. It's mostly held during weekends. It's good for if you just want to boost up your resume. If you just want to show to employers that you can, you're good with CAD. So if you want to take it, I highly suggest you do. I personally took it. So you got the certificate and all that stuff. So this is just really just telling you like how to enter your software and how to log in. If you don't have a SolidWorks account, I suggest you should get one if you do plan on taking the exam, just because you can keep track of all your records. You can even share your designs on the SolidWorks website, all that good stuff. But anyways, what the exam entails is most of the stuff we've gone through. So sketching, extruded boss, extruded cut, modification of key dimensions, basically using that smart dimension tool, revolve, extruded cut, circular pattern, extruded boss, extruded cut, dimensions. So all of these should be pretty, you should at least know what they are based off of what I've done. You should also know like parameters, mates, placing of base parts. So like the fixed and floats is basically what this is. So, are there any things on here that you aren't sure like it is? Because that would basically tell me if I've missed something. But I tried to go over all the stuff that is covered on this exam. So if there's anything here that you might find is new to you, just let me know. But you should have a good idea of everything that's on here. Okay, so just a sample question. Oh wait, there's something on chat. No problem. Yeah, I'll just show you guys a sample question of what was there. These are really just some optional stuff, like optional choice, but the main point we're looking at is right here. It might look intimidating at first, but I promise you it's not that intimidating once you actually get to start working on it. It really is just, they're just asking you to design this using these parameters as shown. So if you really just look at the object, most of the work is just on establishing this 2D shape. So once you establish the 2D shape, you really just use smart dimensions and impute all of these values. So 14, 13, 32, 40, 14, like 7. Once you use the smart dimensions to impute all of those, you just make an extruded boss or base. For C, C is, they should outline it here. C is 43 millimeters. So once you have all those parameters, you really just impute them and use the smart dimension, and that's your part. And as I said before, they don't actually want you to submit your CAD files. They just want you to submit the mass of your actual part. So you use the mass properties features I outlined before, and if it's close to any of these, that's fine, but they're really strict on it. Again, only 1% of your answer is actually allowed, so it's a 1% tolerance. So you just have to make sure you get all of these dimensions right, and you should be fine. The rest is really the same. I'm just modeling parts with parameters and them wanting the mass from you. Yeah, this is just assemblies. For the assemblies, it's pretty easy. As you can see, you can already see here, it's really just concentric mates and coincident mates. Concentric for all the circular connections, and coincident to actually make sure that they're on the same plane as outlined here. So most of this shouldn't be new. Just because you are new doesn't mean you're an expert on it. So I do admit that if you were to take this exam now, if you're completely new to SolidWorks, you might still struggle with it. But again, once you've, hopefully, since you've like worked through the majority of the workshop, you should at least have a good understanding of like where to start from. That was kind of my intention. Most like professionally done workshops are like 9 hours long. At least the one I attended, they're like 3 sessions that are 3 hours long each. So basically I tried to cram most of that into 2 hours by basically giving you a basic framework of it rather than like working through every single feature. So that's why I highly suggest you work and play with SolidWorks on your own, just so you get more experience with it and become more knowledgeable in it. That's basically how I acquired most of my knowledge on it. So I suggest you guys do the same. So again, most of it is really just modeling using these are the answers, but yeah, most of it is really just modeling with your SolidWorks and giving them the math value of it. So pretty straightforward exam. Super doesn't necessarily mean it's easy, but yes.
In part 2, there's this one part, yeah, if you just scroll down, I just wanted you to maybe mention that, especially for the video, because I think just a bit up. Because I feel like it's one of the tricky points. Come up a little bit more. Yeah, over there, there's like this curved edge where there's like this radius R19, right?
Right.
And then there's another line next to it that's like 10 degrees from the horizontal, but then it shows like a tangent line connecting those 2 lines.
Right.
I don't know if that's something that we went over, but like, yeah, that's something that like in this problem.
So basically that's part of sketch relations. I did go over such sketch relations, but I didn't go over that specific one. I just provided like the framework of like what sketch relations are. So basically, if you have, let's say I want to sketch, I have an arc right here. Like that, sure. Then I have a line right here. Wait, no. I have a line here. As you can see on the bottom right of my cursor, you can see that same icon, right? So yeah, that basically means that the arc is tangent to this vertical line I'm drawing right now. So if you, just to confirm, if you select this line, Control, select the arc to go to that same familiar sketch relations. On the existing relations, you should see tangents here. And that's what they were talking about. They just mean that the line should be tangent towards each other. The sketch relation I went over was vertical, which just means they should be on like a vertical axis with each other, but there are other sketch relations. I just provide the basic ones. One of the other advanced ones is like tangent, but it's still the same idea of just like establishing a relation between two different sketches. But yeah, but that's why I highly suggest going over this on your own time, just like explore all the different features using this framework I've sort of provided. But yeah, so that icon you saw previously was really just, open it. Yeah, it's really just saying that this arc right here should be tangent towards this line, this straight line, which is sort of what I did here with like the whole drawing them and like selecting both of them, then selecting that tangent option. That's what they mean by that. Ina, is that good? Like, is that...
Yeah, that clarifies it. Thank you.
All right, no problem. Yeah, really the last couple of minutes were really just me asking if there's anything else you need. It might not be a question, but just like if you want like some sort of resources to help with your SolidWorks journey, just let me know. Let Mina know, then we can give you some stuff. I do have some stuff if you need it. It's really just like PDF of like, for example, I could give you this PDF if you want, if you do plan on doing the exam, just like with all the past questions and stuff. Or you can just message me. I'm really active on Discord, so you can message me there and we can talk more about SolidWorks.
Collins, could you please just share this link, and then I will also send it as an email and just put it on wherever.
Yeah, no problem. I will.
Thank you.
So this is the 2017 SolidWorks system. Share it on chat right now. Good luck for the exam. It shouldn't be too difficult, assuming you prepare adequately. So, I know teachers say that for all exams, but like this one, I'm like, trust me, I did it myself. If you like, just like prepare and just like get used to like all the features and are comfortable with modeling basic parts, you should be fine on it. And that's really all I have for you guys. To those watching the video, thank you for watching. Make sure to play it as many times as you need just to get that good understanding. But yeah, Mina, that's what I got.
Thank you, Collins. And this
Thank you
is
so much.
This is
Yep.
the Redline Discord, by the way, if you guys want to join. That's Collins is a co-founder of this online design community, and it's really cool. So
Yeah, if you're looking for people of your university or different university just to conduct projects with, or attend competitions with, or even prepare for competitions, make sure to hit up the community. We have loads of people who are ready for you. So yeah, if you want to prepare for the UBC Design-a-thon, hit up Redline. We got some people who are going to be eager to join and make a team. So including myself. So
yeah, if Collins is on your team, you're gonna win. So
oh wow, what a compliment.
Just expect a 3D printer from now.
Expect the 3D. Oh, are you gonna have 3D printers?
I think we're gonna have
Actually,
3D printers for first place. Yeah.
Sick. All right, that confirms my application towards the UBC Design-a-thon.
We might have like a blacklist of all the like past winners of the.
No, no, please.
No.
I'll make an alias right now.
But I might restrict you to like the advanced challenge only.
Okay, yeah, that's fair enough. Fair enough.
Yeah, too OP.
Yeah, no problem. Thank you for coming. Along with all the people that are watching our video. Thank you for coming.
Yeah, thanks for this.
Yep, no problemo. Bye, guys.
Bye.